Okay, this section is talking about the area of a triangle. So you might have seen the area of a triangle formula before in geometry class. It looks like this. In this particular section, with the textbook I'm using to make this video, it refers to the area as K, so that's what we're going to use here. So recall that if you have a regular triangle like this, it has a height of h and it has a base of b, here's the formula. K equals 1/2 base times height. And that's great if we have the height, but since we're talking about trig here, what happens if we don't have the height? Is there a way that we can express this without using a height? And as it turns out, yes, there is a way that you can do that. We're going to work with angle C. So let's come up with a trig definition that relates this information. I want to come up with a definition that relates the height to one of the other sides that are here. Now B goes all the way across here, but what I'm going to do is I'm going to form a right triangle, and I'm going to use the right triangle definitions in order to come up with this. So since B is not part of this particular triangle, it only involves A, I'm going to use a definition that involves A and C. So that would be, if I'm looking at angle C here, H is going to be the opposite side, and A is going to be the hypotenuse. So if I want to come up with a trig definition that relates those two, I want to pick sine. So I'm going to do sine of C, that's equal to opposite, that's H, over hypotenuse, which is A. So by doing that, if I solve for H, then I get H is equal to A sine C. So now I'm going to take this and I'm going to put it into this formula down here, and I can derive a formula that does not involve the H. Then I don't need to know H, all I need to know is the angle. Well, if I do that, I get 1/2, and then I have a B here, and then I'm just going to go ahead and stick all this in, the A sine C, I'll put that in place of H, so I get A sine C. So therefore I get 1/2, if I rearrange here, I get this. This is one of my formulas. Now, similarly, if I can show also, I'm not going to show the other cases, but same similar derivation, you can come up with these other versions, and these are going to be in your notes. So here's another one. Here's a second formula, 1/2 AC sine B. And then here's one more, 1/2 AB. The other one is BC here. Let's do BC sine A. That way we have all three angles. So now we have C, we have B, we have A. So here's all three of the different versions that you're going to have in this section. So therefore, you're going to pick the one that involves the sides that happen to be labeled on your particular triangle. So sometimes they'll give you angle C, an angle B, or angle A. That's going to tell you which of the three formulas you're going to use. So now that we've taken a look at where the formulas come from, let's now take a look at an example problem. Okay, now for example, find the area of the following triangle, and we're around the 2 decimal places if needed, and here's the picture that they provide us. Okay, so now what we have to look at is what kind of angle is given and what kind of sides are given in this kind of problem. Well, in this case, we have that angle A, the measurement of angle A, I should say, the measurement of angle A is equal to 30 degrees. So they give us that because, again, that's opposite small letter A, and also they already indicate that these other angles are C and B. Well, because these are labeled that way, I know that small letter B is 3 and small letter C is 4. It kind of goes along with the section on the law of sines and law of cosines that we did before. That basically follows from that. So again, the small letter is always opposite the larger letter. So this is essentially the information that is provided for us from this particular triangle. All we have to do now is look at the three formulas that I just derived earlier and look for the one that has the variables involved. Well, there is one that involves those particular variables, and here's the one that we're going to do. The one that we have is 1/2 BC sine A. That involves everything that we already have done prior. So because we have all that information, all you have to do is just stick it into the formula, and that's going to be the answer. Okay, so we got 1/2 B is 3, C is 4, we have sine of 30 degrees. Okay, now this is actually going to be 1/2, so in this case we can put that in. 1/2, 3 times 4 is 12, this is going to be 1/2. So then you end up with 12 divided by 4, and that gives you 3. We don't need to round to any 2 decimal places in this problem. So this would be your answer. Now there's no units that are given here, If there were, then you would have the units squared on your answer. So this is like inches and inches. You'd have inches squared here because area always has square units. But in this case, because there was no units given, we didn't need to worry about that. So our answer for this problem is just going to be 3. All right, how about another one? Find the area of this triangle, again rounded 2 decimal places if needed. We have A is 2, C is 1, and measure of B is 10 degrees. Okay. So this is even easier because now there's no triangle that's been drawn for us. All we have to do is, we don't even need to take the information off the triangle. We have it automatically provided for us here. Look at your 3 formulas that we talked about earlier. Find the one that has these 3 variables mentioned, and you'll find that the one that we're going to use is this one here, 1/2 AC sine B. That's the one you want to use here. That involves all the information that's been provided. Okay. So the way these problems are set up using this text is usually they're going to give you the correct amount of information so you can use the right formula directly. You don't have to do any other work. Like for instance, they wouldn't give you AC then some other angle because then you couldn't use these formulas. They have to give you the information so you can plug it in. Let's plug it in. And we get 1/2. A is 2, C is 1, and then we have sine of 10 degrees. Well, in this case, the 2's are going to cancel out, and you get K is equal to sine of 10 degrees. And we do want to round that to 2 places, so if you do, you're going to get about 0.17, and that would be rounded to 2 decimal places. That would be your answer. So in this case, just plug the information in directly. We do get a decimal, that's okay. Round to 2 places, that's your answer there. So this would be your area, 0.17.